Hello to all my class 9th champions, class 9th warriors. So welcome back. I hope you guys are really well and you all are enjoying your lives and as well as your studies. Okay, so my dear champion, today in this video I'm going to teach you all the theorems, entire theorems. So a study of circles. So basically we are discussing here chapter number 5 and the chapter name is I am up and down and round and round. So very special name. Okay, so previously this chapter was known as circle only, and now in your new syllabus, new textbook Ganita Manjari, this chapter has given another special name. I am up and down and round and round. Okay, so let's talk about all the theorems. So moving to the first theorem. Okay, theorem number 1. Look at the theorem, guys. So this theorem says that there is a unique circle. Unique means one. Do you know unique? Unique means only one. Unique means only one. Okay, everyone? So there is a unique circle passing through 3 non-collinear points. Non-collinear points means 3 points are there, but all the 3 points are not on the single line. They are not lying on the single line. They are not lying on the straight line. So such points are called non-collinear. When 3 points joining 3 points will give you straight line, so such points are called collinear when 3 points are on the single line. But if 3 points are non-collinear, means the points are not on single line, the points are not on straight line. So this theorem says that if we have 3 non-collinear points, let's assume this is non-collinear points, so only one circle is possible that will be passing through all these points if the points are non-collinear. So when you draw circle, only one circle is possible through non-collinear. I know the circle is look like little weird. I know this is little tilted from this side. So let's do one thing. Take non-collinear points already. So we have, let's say we have a circle here. Right, this is circle. So this theorem says that if you take 3 points, this is the first point, second point and third point. Point number A, point number B and point number C. So these 3 points are called non-collinear points. And how many circles are possible? How many circles are possible? And circles should be passing through these 3 points. Only one circle. There will be only one circle which will be passing through all these 3 points. Only one circle is possible. So this is the first theorem. Clear, everyone? So only one circle is possible that will be passing through 3 non-collinear points. Okay, I hope this is clear to you. Moving to second theorem. Theorem number 2. Equal chords of a circle subtend equal angles at the center. Okay, so let's understand this. So we have circle here and we have 2 equal chords. Do you know chords? The line joining 2 points kept on the boundary of the circle is called chord. So let's say I have one chord and I have one more chord, and both the chords are equal. So please make sure the chords should be equal to each other. So we have 2 chords and let's name this chord AB, and A and B points are on the circle, and we have one more chord, P is on the circle and Q is on the circle. So we have 2 chords, and please listen, the given information here is the length of AB and PQ both are same. Both the chords are equal to each other. And here we go, we have center somewhere here. This is the center. Now this theorem says that equal chords of a circle subtend equal angles at the center. What does it mean? When you join this point to center, when you join this point to the center, we have this angle. When you join this point to point P, when join center from point Q, we have this angle. So the theorem says that angles are also equal to each other. If chords are equal, AB is equal to PQ, it implies that the angle subtending at the center is also equal to each other. So angle AOB will be equal to angle POQ. Guys, in this video I am not going to prove it. Otherwise we can prove it. This will be proved by SSS congruency, SSS congruency. So the angle will be equal to each other by CBSE, corresponding part of congruent triangle. But I'm not going to prove it because I'm giving you overview of all theorem. I'm giving you information about all the theorems so that you guys could use these theorems to do the questions. Okay, so what is this theorem? Equal chords makes equal angle at the center. Clear everyone? For example, I have one more circle, and this chord and this chord both are equal to each other. So if chords are equal to each other, so the angle subtending at the center, this angle, and angle subtending by this chord at the center, this angle, both will be equal to each other. Clear everyone? So this is the theorem number 2. Equal chords of a circle subtend equal angle at the center. Moving to the third. Third theorem says that chords subtending equal angle at the center are equal. So now theorem number 3 is a reverse of theorem number 2. So this theorem is converse of theorem 2. Yes, my dear champion. This theorem is converse of theorem 2. Theorem number 3 is converse of theorem 2. So let's recall theorem number 2 first. So what was the theorem number 2, guys? The theorem number 2 says that, let's say I have a circle, and this is a circle here, and we have two chords, this chord and this. Both the chords are equal to each other. So what was the theorem 2? Theorem 2 says that equal chords subtend equal angle at the center. This angle will be equal to each other. Now what is theorem 3? Here in theorem 2, the chords are equal to each other. This information was already given. And if chords are equal, the angle subtending at the center will be automatically equal. Now this theorem is the reverse. If the angles subtending at the center are equal, now angles are equal, this information is already provided to you. The angle subtending by the chord at the center is equal. So it implies that the chord will also be equal to each other. So theorem 3 is the reverse of theorem 2. In theorem 2, chords are equal, that was given to you, and that's why you guys are writing angles are equal. Angles have to be equal to each other. But here in theorem 3, the angles are equal to each other. This is already given to you. This information is already given to you. So let me show you by using the proper diagram. So I have here, this is the circle, and we have chord. Both the I don't know whether the chords are equal to each other or not. I don't know. This is not confirmed. The chords are equal to each other or not. But one information is confirmed. Chords subtend equal angle. Okay. So this is the center, and here this angle. This is the center, guys. O. And by this chord, this will be the angle, and this is given to you. Angles are equal to each other. This information is given to you. In previous theorem, chords were given equal to each other, and that's why the angles become equal to each other. But in this theorem, angles are equal to each other. This is already given to you. So it implies that if the angle subtending by the chord at the center is equal to each other, it implies that the chords will also be equal to each other. So here AB will be equal to what? PQ. This is the rule. Okay. So here the given information was what? The given information was angle AOB is equal to angle POQ. My dear champion, if angle AOB is equal to angle POQ, it implies that so AB will be equal to PQ. And what was the theorem 2? Given was this, and according to theorem, the angle had become equal to each other. But here, if angles are equal to each other, this is already given to you. So it implies that the sides AB chord and PQ chord will also be equal to each other. Again, I can prove it by side angle side property. So AB will be equal to PQ CPCT by CPCT. But in this video, I'm not going to show you the proof and all. I'm just giving you a single video that will be helping you out to recall all the theorems quickly. So that's why I'm recording this video and providing to you. Okay. Before any exam, you guys can watch this video to remind all the theorems quickly. So this video is very helpful for all the students for this particular chapter number 5. So because without theorem, you guys can't solve the questions of exercise. Theorems are very important to solve the questions. Okay, theorem number 4. Theorem number 4 is the line joining the center to the midpoint of a chord is perpendicular bisector to the chord. Literally, this is very important theorem. This is very important. Not even in class 9th, class 10th also. Very important for class 10th also. In so many questions, this theorem has been used in so many questions in class 10th, and you guys are studying this theorem in your class 9. This is very good. I mean, good thing. You guys will be feeling very confident in circle chapter, and this is the beauty of new Ganita Manjari, right? It will be helping you out to boost your confidence in class 10th. Yeah, so let's move. So we have a circle. We have a circle here. This is circle. And what is this theorem? Listen, look at the theorem. This theorem says that the line joining the center to the midpoint of a chord. So let's draw the chord first. So we have chord here. Okay, this is the chord. And here we go. We have center. This is the center. Center O. Okay. Chord AB. Okay. And O is the center. Chord AB and O is the center. Theorem says that the line joining to the center, center to the midpoint of a chord, this midpoint. Just imagine this will be the midpoint. So if you join a line, if you draw a line joining from center to the midpoint of a chord, it will always be 90 degree and it bisects the chord into two equal parts. And by the way, it is already given to you midpoint, so obviously it will be bisected. So let's say this is a P. So my dear champion, we can write here AP will be equal to PB. Clear everyone? So the line joining from the center to any chord is perpendicular bisector. For example, I have a circle and this is the chord and this is center. If we join a straight line, smallest line, if you draw line this way, so this will not be perpendicular. If you draw line this way, this will not be perpendicular. Smallest line, so the smallest line joining from center to any chord is always perpendicular and bisector. It bisects the chord into two equal parts, perpendicular and bisector. So the line joining from center to any chord is the perpendicular bisector to the chord. The chord divides into two equal parts. Just imagine if AB is of 10 centimeter, right? So what will be AP? AP will become 5 centimeter and the length of PB will be 5 centimeter. It will be divided and at 90 degree. And you know, OP must be, this OP is the smallest line between what? Center and chord. And we all know the smallest line between a point and a straight line is always 90 degree. For example, I have this line, okay, and I have marked a point here, and if I ask you to draw a line from this point to this line, from this point to this line, shortest, we can say shortest also, shortest. So what will be the shortest? This will be the shortest, exactly straight. And if straight means 90 degree. If you draw line this way, such way, like this, so this will be the shortest. And shortest line is always 90 degree. So the theorem is the line joining from center to any chord is the perpendicular bisector to the chord. Clear everyone? Moving ahead. Theorem number 5, the perpendicular from the center to a chord bisects the chord. So basically theorem number 5 is the converse of theorem 4. What is theorem? Let me tell you about theorem. So this theorem says that we have circle here. Okay, we have circle. Look at the theorem. The perpendicular from the center to a chord. Okay, so we have chord here and we need center. What is the theorem? Read the theorem carefully. The perpendicular from the center. Guys, listen. The perpendicular from the center to a chord. So perpendicular will be the shortest line. Clear everyone? The shortest line will be perpendicular, and if there is shortest line, for example this is P and the chord is AB, let's say the chord name is AB and the point where perpendicular is drawn is P. Listen, the perpendicular from the center to a chord bisects the chord. Yes, this is true, because if you draw a line from center to a chord which should be perpendicular, so the perpendicular will be exact at middle. Because when you draw this kind of line, they never will make 90 degree. and they are not at the center also. So the line which is making perpendicular to the chord will exactly the center of the line, and it implies that the chord will be divided into two equal parts. Clear everyone? Listen, I hope this is clear to you. Listen, my dear, this is chord, right? And this line, the line drawn from the center, and the theorem says that perpendicular from the center. So this is perpendicular, confirm this is perpendicular. So if you draw perpendicular from center to a chord, so the point has to be center of the chord, because you can't draw perpendicular this way. These angles will not be perpendicular. These angle will not be perpendicular. Even this angle will not be perpendicular. Even this angle will not be perpendicular. The shortest line will make 90 degree. And the shortest line will be exactly midpoint of the chord. So this point will be the midpoint. Can you see this point will be the midpoint? And if P is the midpoint, it means that the line is perpendicular bisector. So my dear champions, so AP, if angle OPB is equal to angle OPA and is equal to 90 degree, this is given. OPB, OPA 90 degree. So it indicates that P is the what? P has to be, bro. P is the midpoint. P is the midpoint of AB. And my dear champions, if P is the midpoint of AB, so hence AP will be equal to PB. And if AP has become equal to PB, so P is the bisector. So OP is the bisector of AB. I hope this is clear to you. And this is the theorem. The perpendicular from the center to a chord bisects the chord. Clear everyone? Moving to theorem number 6. Chords equidistant from the center have equal length. Okay, let's see. So what is theorem number 6? This theorem says that if you have two chords, look, chords equidistant from the center, chords equidistant from the center have equal length. Okay, so basically the theorem is, if you have chord, one more chord here this side, and this theorem says that chord equidistant from the center. Okay, center is, just imagine center is somewhere here. This will be the center. And what is the theorem? Chords equidistant from the center. It means that the distance of chord AB from the center and the distance of chord PQ from the center, both are same. Let's join. And you all know the last theorem, when you draw a line from center to a chord, it divides chord into two equal parts at 90 degree. By the way, let's ignore this. So this will be the, let's say this is X. The distance of chord from the center, let's say this is X. Okay. And the distance of chord PQ from the center, this is also X. Because the theorem is chords equidistant from the center. So we have assumed X is the distance, X is the distance. And center is, do you know center? This is the center, guys, pink color. This is the center O. Clear everyone? So my dear, the theorem is, if chords are two or so many chords, we can draw so many chords, and all the chords are equal at the equal distance from the center. So this theorem implies that, this theorem says that the length of the chords will also be equal to each other. Wow, equal to each other. If the chords are at equal distance from the center, it implies that chords will be also equal to each other. So AB, the length of AB will be equal to length of PQ. Why? Because both the chords are at the equal distance. Clear everyone? One question, one example I'm giving you. Just look at the question, guys. Example. I have a circle and two chords are there. this is the center. This chord is at 3 centimeter from the center, and this chord is also 3 centimeter the center. The chord AB is here and the chord PQ is here. My dear, if the length of one chord is given to you, like this is of 4 centimeter, right? So what will be the length of PQ? The length of PQ will also be 4 centimeter. Why? Because both the chords are at the same distance. This distance, this is 3 centimeter, this is 3 centimeter. If the chords are lying at the same distance from the center, it implies that the length of the chord will also be equal to each other. The length of the chords are also equal to each other. So, my dear champions, PQ will also be equal to 4 centimeter. This is the answer. I had asked you what is the length of PQ. This was the question. So the length of PQ will be 4 centimeter. Clear everyone? So chords equidistance from, and this is common sense also yaar. Listen, I have circle and this is the one chord and I have one more chord. Two chords are there. Let's say this is AB and this chord is PQ, guys, and center is here. Now the distance of chord PQ from center and the distance of chord AB from the center, now the distances are not equal to each other. Look at the distances. This distance of chord PQ and this distance of chord AB, both are different from each other. Both are having huge difference. So if chords are not equal distance from the center, it implies that the length of chord will not be equal to each other, and the chord which is larger, the chord which is bigger will close to the center, and the chord which is small will be away from the center. This is also true. The shortest chord will be away from the center, and the larger chord will be close to the center. This is also the rule. Clear everyone? Okay, moving ahead. Theorem number 7. The longer of two chords is closer to the center. Oh my God, I have already pitched in this theorem. The same thing is coming here. Theorem number 7. So theorem number 7 says that larger is the chord will be closer to the center. Smaller is the chord will be away from the center. So let's say I have here, this is the circle, and we have two chords. Let's say the first chord here and one more chord here. Look at both the chords, guys. Now if I ask you where will be the center, so center will be here somehow. This will be the center. I hope the diagram is clear to you guys. No. This will be the center. Clear everyone? Now if I ask you which chord is bigger and which chord is smaller, this is absolutely clear. This chord is a smaller size of, and this chord is of bigger size. Let's name this. This chord is AB, and let's say this chord is PQ. What is the theorem? Look at the theorem. The theorem says that longer of two chords is closer. Yeah, here what is given? The length of chord PQ is greater than the chord AB. So my dear champions, the chord which is of bigger length and the chord is of shorter length, shorter will be always away from the center and the larger chord will be close to the center. So my dear, PQ will be what? Will be close to the center, and AB will be what? Away from the center. Away from the center. Clear everyone? And you can see here, no? This line, just imagine this is of 1 centimeter. Imagine, and look at this line. Oh my God. This is far bigger than 1 centimeter. There is much difference. This is 1 centimeter, so this 1, 2, so it might be of 3 centimeter. It is confirmed that this length will be bigger than 1 centimeter. So bigger chord will be closer to the center and the shorter chord, smaller chord will be away from the center. Clear everyone? This is the theorem. Moving ahead. Okay, this is interesting, important, very important theorem. Okay, look at the theorem, guys. Please look at the theorem. Okay, the theorem is the angle subtended by an arc at the center is double angle subtended by it at any point on the remaining part of the circle. Interesting. So let's say we have circle. I'm making little big circle, and so here we have center, Okay, please listen carefully. Let's say there is an angle, this angle at the center by this arc. Let's say name this arc AB. AB. Okay. So here angle AOB. What is this? This angle. This angle. This angle. This angle. This angle. So this is also angle, guys. Arc is an angle. Arc is an angle. So the angle subtended by this arc and taking again same point AB, if we are making one more angle somewhere in the remaining part of the circle. So this theorem says that the angle subtended by this arc will be double of the angle subtended by the same point but in the remaining part of the circle. So let me show you clearly. Let me show you. Let's erase all these things. Okay. And I'm drawing one more line, two more lines here and here. So listen, champion. Please, everyone, please focus. So this is P. Please focus. So this theorem says that if AB arc, this small arc is making angle AOB at the center, this angle AOB at the center. So this angle is always double of the angle in remaining part of the circle. Taking AOB again, but angle is in remaining part of the circle. We are using same points, but angle in remaining part here, you can take here, here, here in the remaining part of the circle. So this theorem says that the angle in the remaining part of the circle is half of the angle making by this arc. And do you know, my dear champion, if you are taking this arc, so the remaining arc will be this, because entire circle look like this. Getting my point? So read the theorem again. The angle subtended by an arc. So we have arc AB and this is the angle here. Angle subtended by an arc is the double to the angle subtended by it, again by it, but in the remaining part of the circle. Again angle A and B is making angle, but the remaining part, but in the remaining part of the circle. So if this is theta, champion, this will be 2 theta. Yes, this is the rule. Getting my point? If you are marking here this angle is x, so it has to be 2x. Or you can take anything here also. If this is 30 degree, it has to be 60 degree. In remaining part anywhere. In remaining part anywhere. Even you can take here also. A small line this and this line. Again, this angle will be half of this angle because this point is lying in the remaining part of the circle. This part is present in remaining part of the circle. Clear, everyone? So dear champions, if this is theta, so what will be this? 2 theta. Clear? If this is 45, this will be 90. If this is 80, this will be 160. If this is 60, this will be 30. Clear, everyone? You can take anywhere in remaining part. Here also. Here also. Yes, dear. Here also. This. Clear, everyone? Clear, everyone? So this is very important theorem. Moving ahead. The angle subtended by a diameter at any point on the circle is 180 degree. Literally interesting. This is called angle in semicircle, guys. Please, you can write in words. Angle in semicircle. So angle in semicircle is equal to 90 degree always. So let me show you practically. Okay, listen. So we have a circle here, and to make semicircle we require a diameter. So this will be diameter. Here we go. We have, this is the diameter. Okay, and this will be the diameter here. Okay, this is A and this is B. AB is the diameter. So this theorem says that angle subtended by the diameter, so diameter is AB, at any point on the circle. So let's mark here like this and this. So this will be angle, and this is always 90 degree. This is the rule, guys. You take anywhere 90 degree. 90 degree. Clear, everyone? This is also 90 degree. Clear? So angle, even here also, because this is also semicircle, the lower half, this is 90 degree. Here also, this is 90 degree. Clear everyone? So angle in semicircle is always 90 degree. Do you know why? Listen, let me show you the proof. Listen everyone. This is here center. Let's say center O. If this arc is making angle theta here. So what will be angle this? This will be theta by 2. Agree everyone? Because theta is lying in this arc. So angle in the remaining part of the circle will be half. Okay. Now do one thing. Increase the angle AOB. Increase the angle AOB. So if I increase the angle AOB, they will become a straight line. Because here this angle was like this. This was the angle. And after increasing the value, this angle was there. And after stretching the angle, it will become a straight line. And a straight line means what? This is equal to 180 degree, guys. And if this is 180 degree, now join this line. This will be 90 because half of 180. 180 is in this arc. So in remaining part of the circle, that has to be 190 degree. Listen, this is 180 degree. And if you take here, so it has to be 90 degree, the half of 180. And that's why a straight line is equal to 180. So half of 180 will be 90. And half of 180 will be lying in the remaining part of the circle. If you take this side 180, so this will be the remaining part. Now this will be 180. If you take 180 this side, so this will be the remaining part. It has to be 90 degree. So angle in semicircle is always 90 degree. Okay. So this is not theorem. Basically this is corollary, because this is the result, guys. This is the result of theorem number, the last theorem. Basically this is corollary. Corollary means what? The result, and result of theorem number 8. This is theorem number 8, and the result of theorem number 8 is corollary. And this is angle in semicircle, because a straight line is equal to 180 degree and the half of 180 will be 90 degree. So always angle in semicircle is 90 degree. Moving to last theorem, theorem number 10. The sum of either pair of opposite angles of a cyclic quadrilateral. Can you see here? Cyclic quadrilateral, guys. This is very important term. Cyclic quadrilateral. Cyclic quadrilateral, when a quadrilateral is inscribed in a circle, or we can say when the circle is circumscribed of a quadrilateral. A quadrilateral is inside the circle, or we can say a circle is outside the quadrilateral. Both are same. So we have a circle here. Oh, sorry. This is not circle. We have circle here, and now there is a quadrilateral. This is the quadrilateral. Let's say this. This is quadrilateral. Please name the quadrilateral A, B, C, and D. Okay, so the theorem says that now this quadrilateral is called cyclic quadrilateral because the quadrilateral is inside the circle. Cyclic quadrilateral means what? Quadrilateral, what? Inside the circle. Right? So this is called cyclic quadrilateral. Any quadrilateral, whether you can draw a square, rectangle, trapezium, whatever. Clear? And the theorem says that the sum of either pair of opposite angle. So if we add angle A with angle C equal to 180 degree. They are equal to 180 degree. If you add angle B with angle D, they are not equal to each other. I am not saying equal. No. The sum will be equal to 180 degree. So the angle A plus angle C is equal to 180 degree, right? And angle B plus angle D is also equal to 180 degree. The sum of opposite angles, so the opposite of A is C, the opposite of B is D, so the sum of opposite angle in quadrilateral is equal to 180 degree. So let's use in a question. So let me show you example. Find the value of x. Find the value of x. This is the question. Find the value of x. The diagram is given to you. Look. Okay. So my dear, this is x here. and ABCD is a quadrilateral. And it is not necessary that every time it will be mentioned that ABCD is cyclic quadrilateral. You have to understand, if the quadrilateral is inside the circle, it has to be cyclic quadrilateral. So don't wait, the information should be there, this is cyclic quadrilateral or not. If the quadrilateral is inside the circle, this is definitely cyclic quadrilateral. That will be cyclic quadrilateral. So what will be the value of x if this is equal to 60 degree? Tell me, if this is 60 degree, angle C, so the opposite of angle C is A, and according to theorem, the sum of opposite angles are equal to 180 degree. So my dear, x plus 60 will be equal to 180 degree, so x will be equal to 120 degree. Answer. Simple. So this is all about. So thank you so much for watching this video. It really it will be helping you guys to revise, to recall all the theorems very quickly before your exam. And one very important news, I would say, very important information for all the students of class 10th and 9th. So my dear champion, the information is Vedantu has launched something unique for all the students. If you guys are struggling, if you are in class 10th and if you don't know how to prepare for the board exam, if you are confused about notes, assignment, question practices, as aligned to the CBSE new curriculum, according to CBSE, it is really challenging for the student to get the relevant contents, relevant academic material that could help you out for your board exam. So Vedantu has launched, my dear, all in one. There is a page, there is a website, academic page, where you get all the information, assignment, questions, and whatever we are teaching you guys, all the calendar will be there, recorded videos will be there, so you don't need to move here and there. At one place, everything will be available. So let me show you a short glimpse for this. Okay, so my dear champion, so basically this is the page, this is the interface will look like. So my dear, if you go to, now the question is how to come on this platform, how to get this interface. Don't worry, I'm going to show you everything. First look how the interface, okay, so let's do one thing. So my dear, to get this link, you have to go to our official YouTube channel, and our official YouTube channel is Diksha Vedantu CBSE English. Go to the Diksha Vedantu CBSE English. On this channel, you can go any video. For example, this is my first, the recent video. Click here. Let me pause this. So now after coming here, go to description, video description. So in video description, the link will be given to you. Both the classes. This video is related to class 10th, so the class 10th link is given there. By the way, class 9th link will also be given there. Both the links all together. Can you see? So if you are in class 9, click here. If you are in class 10, click here. So let me show you. After clicking on that link, this interface will open to you in front of you. So this interface is fully AI powered classroom. You will be getting live classes by master teachers, weekly assignments. So we are providing you weekly assignments, and you can get here only 40 plus part and full-time test, and all the tests aligned to CBSE new curriculum. Competency based questions will be there, everything that you genuinely required. Unlimited access to post class replays, all the videos will be here. And what the videos, all the videos that has about to come, that are all the videos that those are about to come in future, all the calendars will be reflecting to you. Okay, every information, when respective teacher who will be taking the next session, so every details information will be here. So now on clicking buy now, you have to, after clicking on buy now, you have to put your register mobile number. There will be an OTP come in your phone. After putting OTP, you will be granting access to this page. Everything will be there. Subject wise, you can get all the session PDF, assignments, quiz, questions, everything at one place. So my dear, don't jump here and there, different websites, different YouTube videos. Don't get confused, because this is very crucial time. So this entire page, this one platform is enough for you, because you get each and everything here regarding competency question, formula sheet, assignments, quiz, everything, right? So this is very important. So don't, without any delay, go and enroll now, so that you can get advantage of this all in one page, one place, so many solutions. Okay, so if you are aiming to come into 90 plus club, if you are serious for the board preparation, so this page is exclusively designed for all class 10th champions. And for 9th also, if you are in 9th class, guys, you can click on the links, the second link, join the free class. You don't need to pay anything for this class 9 course. Now after clicking on this, same interface will come in front of you, right? Clicking on buy now, putting your number, OTP will come and everything is there, right? So I hope you really enjoyed the session, and don't forget to subscribe the channel. If you haven't subscribed the channel yet, go and hit the subscribe button. Thank you so much. Take care of yourself and take care of your parents.